We'll look next at how we actually measure the content of water that is being held by the soil within this profile. One of the methods that we have for measuring the quantity of water which is held in a soil is called the gravimetric water determination. Basically, this is nothing more than taking a sample of soil, weighing that soil, which will be determined to be the wet weight of the soil. Then we place that soil in a drying oven at approximately 105 degrees centigrade for 24 hours, which will remove the moisture that's being held in that soil. Now, it will not remove all of the moisture, but it will remove it down to a level which approximates that amount which plant roots growing in that soil could withdraw could withdraw water from that soil. After we've dried that in a soil's drying oven for approximately 24 hours, we then reweigh the soil and get a dry soil weight. So the wet weight is the content which we initially take the sample out of the field. The dry weight is after it's been dried in the oven for approximately 24 hours. This is going to give us the quantity of water that is being held in that particular soil volume or soil weight. So we take wet weight minus dry weight divided by the dry soil weight. And then since we want this expressed as a percentage of water held by the soil, we then take this number times 100 to convert to percent of water. Now, one might ask themselves, why do we divide by the dry soil weight rather than the wet weight, since the wet weight represents 100% of soil plus water? And the reason for that is that if we utilize the wet soil weight as our basis for comparison, then every time we change the water content of a soil, we're changing our point of comparison. So the only constant in this equation is the dry soil weight. Therefore, we must divide by dry soil weight in all cases in order to determine the water content held as a percentage of the dry weight of the soil. So this seems like kind of a misnomer, but we're looking at water percent on a dry weight basis. And then, of course, the 100 multiplying times 100 converts this decimal into a percentage point. So if we had a soil sample that weighed 100 grams wet and 80 grams dry, that would be a total of 20 grams of water. That 20 grams of water is not being held in 100 grams of soil, it is being held in this 80 grams of soil. So the 20 grams divided by the 80 grams, the dry soil weight, you can see that's a ratio of 1 to 4. 1/4, of course, is 0.25 or 25%. So in that particular example, we would have a gravimetric water content of 25%. This method of evaluating water held in the soil is obviously fairly time-consuming. We are taking soil samples from the field into the laboratory, drying them in an oven, and then calculating the percentage of water that is held. So it is not a direct measurement under field conditions, it's a laboratory-type technique. Because we've done this for a long time and because it's kind of somewhat of a standard in the industry, it's not necessarily the method that's going to be utilized under field conditions, but it is a method that we oftentimes will use to calibrate other types of measuring equipment, soil moisture monitoring types of equipment. So we do need to know how to determine the gravimetric water content of a soil, and after I look at the next method of expressing soil water content, we'll be looking at an example problem or two as to how and when we would utilize this.